Awesome. So, as we are doing every week, we are covering 2 chapters a week. But as I had said prior, if you just so happen to go ahead, it's totally fine. There's nothing holding you back from going 2 chapters at a time unless you want to. It is possible to complete this class faster than how I'm going through it. But to be cognizant of your time, I'm going 2 chapters at a time. So today will be chapters 5 and 6. Networks and storage. So first up will be networks. There are only 2 sub-lessons. The first will be the standard switches. In order for our virtual machines to connect, to talk to one another, and to connect to the real world, we need a virtual switch. These things allow our virtual machines to not only connect with each other, but also do things like replication, to manage fault tolerance, so on and so forth. A virtual switch is or functions in the same way as a regular switch. It is not a smart switch where you can connect to it and you would get a command prompt that you could configure it. It is more of a layer 2 type switch that doesn't have any smart configurations in the traditional sense. It is very easy to create a switch within networking. You would, within a host, for example, you would go to configure, and under configure, you would add a new virtual switch, and you could choose either a VM kernel network adapter or port group for a standard switch. One of the great things about virtual switches is, well, they're all software based, so they're not really real. Because they're not really real, it is possible to have many of them in your hosts. So for example, you could have one big virtual switch and it has all the ports for everything. So you have your management, which would get you to the website to manage vCenter and everything else. You have vMotion. Maybe you have a couple of production systems, a couple of testing, iSCSI if you have a iSCSI server for your storage, and then the actual physical ports that connect out to the world. You could do that. That would make networking pretty easy because all configuration would run through one switch. Or what you could do is have separate virtual switches for everything. In this sense, we could have one virtual switch that handles nothing but management traffic, and it would go out certain physical ports, one for vSphere and against vSphere vMotion, and certain ports. Production will come out of one way, test will come out of another way, iSCSI will come out another way. On this side of the switches, where everything is virtual, this is all data flying back and forth. The switches determine where the communication goes, and we'll kind of explain how it functions in a couple of slides. But it is possible to have, kind of like you have your physical rack with different switches, you can divide everything out virtually. A standard switch, like I said, allows our virtual machines to connect out to the world, whether it's to each other and out or both. So here's an example of VM1, who is connected to a switch all its own, connected to a physical card, a physical NIC, and out to the world. So in this first setup, this virtual machine is connected all on its own to a virtual switch, who is then connected to a physical card and connects out to the real world. VM 2 and 3 are connected to a second virtual switch, but they're only connected to each other. This means VM2 cannot get out to the world unless there are some routing rules in VM3 that allow VM2 traffic to go out through the virtual switch, up the VM, and out the door. Otherwise, VM2 will remain disconnected from the world. We have IP storage if we're managing any like iSCSI, and our management network that controls everything. Again, because this is all virtual, we can do a lot with this. You can view some of the settings that we can edit in a switch. And again, you don't have that many in a virtual switch, but you can. For example, the port group, you can edit right here under edit. You see all the switches that are available. One cool thing about our virtual switches or V switches is they can all handle VLAN tagging. So you can have a virtual machine in your infrastructure connect to a real VLAN on your physical network. So it is completely possible to take, let's say, an accounting server on a company infrastructure, turn that server virtual, set the end workstations into VLANs, and set the server into VLAN, and they'll all be able to talk to one another. VMware understands any VLAN tagging and will use it as such. Now, because we're going out through physical cards eventually, the bottleneck is not on the virtual NIC, or the virtual switch, because that's all happening within the CPU. The bottleneck becomes the physical card. So if you have a card that is not fast enough to handle the traffic that's coming out, that will be your bottleneck. This is why you want to ensure that your servers have the fastest cards that have a direct connection to the backbone of your entire infrastructure. Because in situations like this, where end devices are connecting into virtual machines, they're going to need the fastest connection in. Now, there are two types of virtual switches. There's the standard, which we've been talking about, and also the distributed. The difference between the two is a standard switch lives in a single host. A distributed switch can live throughout the entire data center. So with a virtual switch, with a standard virtual switch, I can take one ESXi host and create the switch. It's going to live in that host and that host only. If I have two ESXi servers and I create a standard switch on host A, it will not exist in host B. In a distributed switch, they'll be managed by vCenter and be available on all hosts. This last note right here, both switch types are elastic. They're elastic because they're software. Because the software doesn't have a physical limitation of how many ports exist in a switch. So, a distributed switch, again, managed by vCenter, they can span the entire data center, which is great if we have multiple applications or multiple operating systems, multiple virtual machines running on different hosts, and we want the same host to go out the same way. So, quote, the same way through the same switch. We will create a distributed switch, so it doesn't matter what physical host the VM is running on; it will go out through the same switch. This becomes important if we have VLANs. Then we need to make one distributed switch that virtual machine will be able to talk through any host, any physical host. If this gets confusing, please Please say so in the chat, either Zoom chat, YouTube, or Discord. vCenter does give a distributed switch a little more power. For example, in a standard switch, we can't do things like inbound traffic shaping or net flow or port mirroring, but we can do all those things in a distributed switch. Now the policies. These are basically the settings of switches, but we can define what they can do, what they can't do, how will they handle certain traffic, how will they handle NIC teaming, and so on. As an admin, you can define some items like will the virtual switch or the group forward traffic regardless of the destination. If you are running things like Suricata, Wireshark, TCP dump, Moloch, you would maybe want to enable promiscuous mode. If you need to change the MAC addresses, because they may get rejected, you can enter that there. You can also do forged transmits on any packets that come in and out. There are options to handle bursts, because sometimes for example, at the beginning of a workday, there's going to be a much higher traffic than during the middle of the day when everybody is working. When everyone initially logs in, they're going to get those workstations are going to pull information from the server, so you're going to have a sudden burst, and that burst won't stay, but you can define how much burst we want to give these virtual switches. And this is all defined in traffic shaping. It's normally disabled, but you can enable it so that one or a couple NIC cards don't get overwhelmed. Because this is all virtual, we are able to define NIC teaming and failover. So what happens when a NIC card dies, or what happens when the cable that the NIC card is connected to is out, or the physical switch is out? The virtual machines need to stay connected, so we can define more active adapters to add to this list, so that if and when a NIC card dies, traffic just gets rerouted to the next NIC so that everything continues. Now, this diagram may look a little crazy, but this is kind of how it thinks. The virtual switches understand where traffic is coming from and are able to redirect that traffic back. So if the VM at the bottom of this diagram needs to connect out to this computer, and let's say this physical NIC card is busy, well, the virtual switch is able to divert that traffic to a different network card and out the door into the real network and to its destination. Same thing with our top VM over here. If this is the default way, the shortest way, and everything is good, it'll use that road. But if a NIC card is busy, or if the NIC card is disconnected, the virtual switch is able to determine what other NIC card can we get traffic out so that it reaches the real world and is able to return back to the VM as needed. We can also do this by MAC address. So we can use the virtual port ID. We can also use MAC address. We can also use IP hashes as well. These are all different ways that vCenter ensures that traffic leaves out through our virtual machines, reaches their destination, and is able to return. Now, the VM kernel, part of the suite, uses things like beaconing in order to see when and if there is a network failure. Then it will either use any of the failover stuff that was set up earlier, like if NIC card A dies, then use NIC card B, or do any load balancing if it's been set up. Your physical network environment has to be considered uh, as you plan out your data center. Your whatever physical switches are directly connected to the servers that are running these virtual machines, you need to take quite a number of things in mind. For example, how many switches do you have? The network bandwidth that you're going to need depending on the number of virtual machines that'll be connecting out to the world. Uh, will you use 802.3AD for NIC teaming? If so, does the physical switch need to understand that? Uh, are you going to do VLAN tagging? If so, you're going to need a switch that understands 802.1Q. Does the physical switch support LACP? Does it also support LLDP and CPD? Because these modes are also used by the V switches. And you'll have a lab to play with the standard switch. Any questions on a virtual switch, both the standard and the distributed? Okay.